Okay. All right. Problem number 25 is more of the same stuff. We're going to have x squared minus 2x plus 1 all over x plus 5 is equal to 0. Now this one's so simple you might think that it's hard. Here's the temptation. The first temptation is a lot of these problems are rigged up to where you do the prime factorization in the top and it'll cancel with the bottom sometimes. That isn't the case here. Okay? So because the factorization to get -2, this is literally, well, let's do it just for the fun of it. This is x minus 1 times x minus 1 all over x plus 5. So remember Mr. Adams said that we should probably do the prime factorization at some point in time of the top and bottom, sometimes depending on the situation, especially in the denominator when we're trying to find the common denominator. X plus 5 is prime already. In other words, I can't factor anything out. But this stuff up top isn't prime. All right. So I factored it. Nothing cancels. It's still equal to 0. Well, 0 is the same as 0 over 1. Right? Now, what do you see there? I see a fancy proportion, but it's really just a proportion. Does anybody remember how to solve proportions? Cross multiply. So I'm going to multiply that. Oh, yeah. Oh. And multiply that.
You get x squared minus 1 over 0.
Yeah, so 1 times this stuff, the stuff in red is just going to be x minus 1 times x minus 1 times 1, which is just itself. And then what's 0 times x minus 5?
0.
Yeah, remember, for argument's sake, we should probably remember that it's 0 times this, but when you distribute the 0 through the parentheses, you still get 0. Well, that's all right. So then x cannot equal 1 and x cannot equal 1, right? Because we got to say x minus 1 equals 0 and x minus 1 equals 0, and then we get that. And why did I say cannot equal? Because I'm still stuck in the denominator mode, right? So it's x equals 1 and x equals 1. Now, those are the answers. We think the solution is x equals 1 multiplicity 2, right? But what do I got to do at the end every time? Plug it back in to check for. Yeah, because it might have a problem in the denominator. So if I plug it back in, what will I get in the denominator? In other words, if I plug in a 1 for x, what will I get? 6. Is that okay?
Yeah.
Absolutely. Okay, so then we can keep that answer. Any questions on that?